The modern diet has undergone a dramatic shift, with carbohydrate consumption reaching unprecedented levels. This transition did not occur by deliberate choice but rather as an evolution driven by convenience, fast-paced lifestyles, and the increasing availability of processed foods. Many people today make dietary decisions based on immediate hunger rather than careful planning, opting for meals that require little to no preparation. The time-consuming processes of soaking legumes, steaming vegetables, and preparing whole foods have given way to quick and easily accessible alternatives. This shift has resulted in a heavy reliance on carbohydrate-rich foods, which now dominate the average diet. The consequences of this dietary transformation are becoming increasingly evident, prompting questions about its long-term effects on health. The realization that excessive carbohydrate consumption carries consequences did not happen overnight. Decades ago, concerns began to emerge as people sought solutions to weight gain and metabolic issues. Early discussions about the impact of carbohydrates on the body faced significant resistance from the medical community, yet the public response was markedly different. Those who experimented with reducing carbohydrate intake often found that it yielded tangible results. The appeal lay not just in theoretical claims but in practical outcomes. As more individuals began experiencing weight loss and improved metabolic function, curiosity about the underlying mechanisms grew. To understand the physiological effects of carbohydrate consumption, it is necessary to examine the biochemical processes that occur within the body. All carbohydrate-based foods, regardless of their source, undergo breakdown in the gastrointestinal tract. This breakdown results in the formation of glucose, a simple sugar that serves as a primary energy source. Once glucose enters the bloodstream, it travels through the portal vein to the liver, where it is processed and distributed according to the body's energy demands. The body's ability to manage glucose efficiently determines whether it will be used for immediate energy, stored for future use, or converted into fat. Within the cells, glucose follows a structured metabolic pathway to generate energy. The initial phase occurs in the cytoplasm, where glucose undergoes a 20-step process to produce pyruvate, a chemical derivative of glucose. This pathway, known as glycolysis, results in the production of 2 units of adenosine triphosphate, the molecule that stores and transfers energy within cells. While this energy yield may seem modest, it is significant because it represents the body's ability to produce energy without oxygen. This process, termed anaerobic metabolism, plays a crucial role in specific situations where oxygen availability is limited. Beyond the cytoplasmic phase, the metabolic journey continues within the mitochondria, the energy-producing organelles often referred to as the powerhouse of the cell. Pyruvate enters the mitochondria, where it undergoes further transformation in an oxygen-dependent process known as aerobic metabolism. This phase, involving an 8-step cycle, produces a significantly higher energy yield, generating 36 units of adenosine triphosphate. The stark contrast between anaerobic and aerobic metabolism highlights the fundamental role of oxygen in energy production. The difference in energy output between these pathways raises important questions about their implications for health. Anaerobic metabolism, which produces minimal energy, is primarily employed during short bursts of intense activity or in environments where oxygen is scarce. It is also the preferred energy pathway for certain types of cells that thrive in low oxygen conditions. In contrast, aerobic metabolism, which relies on oxygen, supports sustained energy production and efficient cellular function. This distinction is particularly relevant in discussions about disease processes, as some abnormal cell behaviors are closely linked to metabolic pathways. One of the most significant observations in this regard is the metabolic behavior of cancer cells. Unlike healthy cells, which utilize oxygen to generate energy efficiently, cancer cells predominantly rely on anaerobic metabolism. This reliance on fermentation allows them to rapidly consume glucose at a rate significantly higher than that of normal cells. The high glucose demand of cancer cells has been well documented, leading to the understanding that they thrive in low oxygen environments. The implications of this metabolic preference are profound, suggesting that the body's energy pathways may play a role in the development and progression of certain diseases. The connection between glucose metabolism and disease extends beyond cancer. Metabolic disorders, including diabetes and obesity, are closely linked to the body's ability to regulate glucose effectively. When carbohydrate intake is consistently high, the body's regulatory mechanisms can become overwhelmed, leading to insulin resistance and impaired glucose metabolism. The excess glucose that is not immediately utilized for energy is stored as fat, contributing to weight gain and metabolic dysfunction. Over time, these disruptions can set the stage for chronic health conditions, emphasizing the importance of understanding the long-term effects of dietary choices. As awareness of metabolic health grows, there is increasing interest in dietary approaches that prioritize balance and sustainability. Reducing reliance on processed carbohydrates and emphasizing nutrient-dense foods can play a key role in maintaining metabolic function. While carbohydrates remain an essential part of the diet, their quality and quantity are critical factors in determining their impact on overall health. Whole, unprocessed sources of carbohydrates, such as vegetables, legumes, and minimally processed grains, provide essential nutrients and fiber that support digestion and metabolic stability. In contrast, refined carbohydrates, which are rapidly absorbed and metabolized, can contribute to blood sugar fluctuations and energy imbalances. The modern diet's evolution has been shaped by convenience and accessibility, but growing awareness is prompting a re-evaluation of its consequences. Understanding the biochemical processes behind carbohydrate metabolism sheds light on why dietary choices matter. The body's energy pathways, particularly the contrast between anaerobic and aerobic metabolism, reveal fundamental principles of health and disease. As research continues to explore these connections, the importance of mindful eating and balanced nutrition becomes increasingly clear. A return to whole, nutrient-dense foods may offer a path toward better metabolic health, reinforcing the idea that the way food is consumed today will shape health outcomes in the future. The way we fuel our bodies has a profound impact on our health, energy levels, and long-term well-being. Understanding how carbohydrates break down, how they affect metabolism, and why balance is key can help us make better dietary choices. The modern diet, driven by convenience, has led to excessive carbohydrate consumption, but knowledge empowers change. Prioritizing whole, nutrient-dense foods over processed options can support metabolic health and overall vitality. If you found this information valuable, don't forget to like, share, and subscribe for more insights on nutrition and wellness. Thanks for watching, and see you in the next video.